Very good morning, dear friends. In the previous class, we have started a chapter, Microencapsulation. In this, we have gone through few introductory part. In case of introduction, we have seen what exactly the meaning of microencapsulation is. Second one, we have seen what are the different components of microencapsulation. Third one, we have seen what exactly the size range of microencapsules. Then the next one, we have seen what are the different reasons of microencapsulation. We have defined microencapsulation, that is application of relatively thin coat on the surface of solids or droplets of liquids and dispersion. We have seen its a size range. It is in the range of 50 micron to 5000 micron. We have gone through the different components, and in that we found that a core material and coating materials are the different components of microencapsulations. While seeing what are the different reasons for microencapsulation, we have come to know that if you want to have a sustained or controlled release effect, if you want to improve the patient compliance, if you want to mask the taste and odor, if you want to convert the liquids into solids, if you want to protect your drug from the various environmental conditions, if you want to reduce the toxicity, or if you want to reduce the GI irritation, the best option that is available is none other than microencapsulation. See, in the today's class, actually we are going to cover around about 3 different beats. One is what are the different release mechanisms. What are the different mechanisms by which actually the release of drug from microencapsulation takes place? What are the different types of coating materials that are utilized for microencapsulation, and what are the different properties, desired properties that are needed for any coating material to use as a coating material in microencapsulation. Let us start the session with a very new bit, that is release mechanism. See, especially for the microencapsulation, 4 different mechanisms are used. Number 1, diffusion. Number 2, dissolution. Number 3, osmosis. And number 4, erosion. It is very essential for everyone before they start to know each and every bit, whatever the term that is through which only the bit is going to be started, one should understand its mean. Here actually the first mechanism by which actually the microencapsulation it releases, that is a diffusion. My question is, what is diffusion? If a candidate is not having an idea regarding what exactly the meaning of diffusion, and if you started to understood the concept, it is very difficult to understand that. Let us start with the definition. If someone asks you what is diffusion, your answer must be a flow from higher concentration to lower concentration. Now the question arises, how this diffusion is responsible for releasing the content from the microencapsulation? Let us see. See, diffusion is the most common mechanism. In this, dissolution fluid, that is surrounding to your microencapsules, that penetrate inside the shell, it dissolves the core material and leak out through the channels or the pores. See, the rate at which actually the drug releases, it depends upon the variety of factors. The first factor on which actually rate of drug release depends, number 1, the rate at which the dissolution fluid it penetrates inside. It also depends upon the rate at which your drug dissolves into the dissolution fluid, and it also depends upon the rate at which the dissolved drug leak out and disperse from the surface. See, this is one. Another mechanism by which actually the release from the microencapsulation takes place is dissolution. Now once again the question arises, what is dissolution? It is generally defined as when a solute it is dissolved in a solvent and it forms a solution. It is called as a dissolution. Then how it is related with the release mechanism? See, in this mechanism, dissolution of polymer coat takes place. Dissolution rate of polymer coat, it determines the release rate of drug. Now, what are the different factors on which actually the dissolution rate of that polymer coat, it depends. It depends upon the thickness of that polymer coat. More the thickness, lesser will be the rate of drug release. It depends upon the solubility. The solubility of coating membrane into the dissolution fluid. So this one is what? A second mechanism through which the release from microencapsules can take place. Now the third one. The third mechanism is osmosis. Once again, the same question arises. What exactly the meaning of osmosis? The movement of solvent particles across the semi-permeable membrane from low solute concentration to more solute concentration. See, here in this case, a polymer acts as a semi-permeable membrane, which allows the creation of osmotic pressure difference between inside and outside microcapsules, which drives the drug solution out of microcapsules through the small pores in the coating membrane. So this is all about what? This is all about a third mechanism that is called as a osmosis, through which the release of drug through the microencapsules takes place. Let us have the fourth mechanism through which the drug is releases, that is erosion. Question arises, what exactly the meaning of erosion is? A degradation of exterior surface. Generally, degradation of surface or degradation of anything, that is called as a erosion. How exactly this erosion is responsible for releasing? As we know that a core material is surrounded by a coating material, and once the degradation of coating material takes place, it may lead to the release of a core material that is your active ingredient. What are the different factors because of which the degradation or erosion of coating material takes place? See, it is because of pH and enzymatic hydrolysis, or it may be because of a combination of pH and enzymatic hydrolysis that causes the drug release with the certain coating materials. For example, a coating material prepared of glyceryl monostearates, a coating material prepared of beeswax, a coating material prepared of stearyl alcohol. These are the different materials. They may get it degraded, they may get it eroded, and because of which what happens, a core material, it may comes out and release takes place. So like this, these are the four different mechanisms, namely number 1 diffusion, number 2 dissolution, number 3 osmosis, and number 4 erosions. Next one. Today actually we want to see one more bit, that is what are the different types of coating materials that are used specially for the preparation of microencapsules. See, generally different types of resins are used for the preparation of microencapsules, and that acts as a coating material. What are the different types of coating materials that are used? Number 1, water insoluble resin. Number 2, water soluble resin. Number 3, different types of waxes and lipids. And number 4, enteric resin. Once again, the question arises, what are resins? See, resins are the solids or highly viscous substances of plant or synthetic origin that is typically convertible into polymers. Resins are usually mixtures of organic compounds. Do you know, plants actually secretes resins in response to the injury for their protective benefits. Okay? So such resins can be used as a coating material, and that entrap the core material and acts as a what? A microencapsules. Chalo, let us see what are the different types of water soluble resins. See, gelatin, gum arabic, polyvinyl pyrrolidone, carboxymethyl cellulose, methyl cellulose, arabinogalactone, polyvinyl acrylate, polyacrylic acids. These are the few examples of water soluble resins that can act as a coating material. Another one, water insoluble resins. In this actually ethyl cellulose, polyethylene, polymeth acrylate, cellulose nitrate, and different types of silicones. This used as a water insoluble resins. The third category of a coating material, that is none other than waxes and lipids. In that, different paraffins, carnauba wax, beeswax, stearic acid, sterile alcohol. This belongs to the category of waxes and lipids. And the fourth type of coating material that is used in case of microencapsulation is the enteric resins, which includes shellac, zen, cellulose acetate phthalate. We used to call a cap, that is what? Cellulose acetate phthalates. So these are the four different types of materials particularly used as a coating material in order to coat the core material. Our next bit is, are all the type of coating materials are suitable to prepare the microencapsulation? No. There are few desired properties. There are few desired criterias. If any coating material, once it obeys, then and then it can be used as a coating material. Chalo, let us see what exactly the desired properties of coating materials, or what properties it should have. Number one, it should stabilize the core material. If you are using any coating material in combination of a core material, your coating core material, it should not get it disturbed. It should not form any kind of a incompatibility. It should stabilize your core material. One. Another one, it's a nature, it must be non-reactive. It must be inert in nature towards its active ingredients. Otherwise, what happens? Once again, it may responsible for what? It may responsible for any type of a incompatibility, either physical, either chemical, or any type of what we can say a therapeutic incompatibility also. Whatever the coating material that we are using in any specific condition, it should releases the content in a controlled manner. What we can say, a controlled release under any specific conditions. If it obeys, surely that can be used as a coating material. Another one, if you are using any coating material, it should be a pliable, it should be testless, it should be a very stable, and it should form a film. See, this formation of film is responsible for what? Retarding the content, retarding the release profile of a particular drug. That's why actually it should form a film on the surface of a core material. ठीक है. Another one, the coating material that we are using, it should not readily acquire a moisture from the environment. We can say that it must be a non-hygroscopic. Regarding its viscosity point of view, it should not possess a high viscosity. Regarding its price, it should not be a very costly. It should be a very economical. Otherwise, what will happen? If its cost will be more, ultimately it will affect on the cost of production and the cost of formulation. Again, that will be more. Okay. The next one, it must be soluble in aqueous media. It must be soluble in different types of solvents. Regarding different types of waxes and lipids, it should get it easily melted. That's why that may help in order to prepare what? Different types of a microencapsulation. Regarding overall nature, if you want to tell, regarding the coating material, it must be amenable, it must be flexible. Again, so formulator can mold whatever the requirement that he is expecting from the coating material. It must be brittle sometimes, it must be sometimes hard, it must be thin. See, if it is a very thick, ultimately it may retard the content in up to such an extent that expected release is very difficult to come out. So these are the few things regarding the coating material properties. See, this is all about the 3 bits today that I have taken regarding first one. What are the different release mechanisms through which actually a drug is releases from the microencapsulation? What are the different types of coating material that are needed for the preparation of microencapsules, and what are the desired properties or ideal properties for any coating material to be used in a combination with core material in order to prepare the microcapsules. This is all about the second session. I will once again come with the third session, and in that actually we will see different methods of preparations of microencapsules. Till then, thank you very much and goodbye.